Hello and welcome back to Compiler Programming. Today I want to continue working on some refactoring that I've been doing for a bit now, and I think that's pretty important to what I'm trying to achieve in the long term. And what happens is that originally I did this tokenizer, so if we go into here, we have the function tokenize, right? This is a pretty standard tokenizer. Basically, you go over each character in input and you change the state and do some action and you push out some tokens. So for example, let's take a look at, this is pretty good option. So we check if the character is an operator and we mark that as a start of the token, and then we change as the state of the tokenizer to that particular token, and then we do some actions later on. So here's our operator, right? Once our character is no longer an operator, we push the current token and then we continue with tokenization. The thing is, we also have this concept of the value token. So here you see token tag value, and it started with just integers, then I switched strings, and then I switched identifiers recently. And the idea is that since this language allows me to interact with sort of any values present in the language at compile time, I need to be able to mix and match tokens and the values in a single kind of expression, or just a list of values, I guess, or tokens. And it just made sense that I would need to either wrap a token into a value or a value into a token. And I decided to wrap a token into a value. But now that I'm looking at it a bit more, I realize that the whole concept of token doesn't really make sense for this specific language that I'm trying to write. And what I'm doing is I'm slowly taking the token types that are there. So set first integers and strings and now IDs, and I'm transitioning them into being just values wrapped in this token tag value, and at the point where this would be the only type left of tokens, I will just remove the tokens altogether, and they will no longer exist in a program at all. Instead, you will always manipulate values. It's just that those values will have a very specific type. Okay. So today I just wanted to kind of talk through that and explain what's happening, and additionally I want to tackle something simple, something like taking an operator and also transitioning into values. Now, another thing about operators is that right now operators are a bit special. They are different from the identifiers in that they are, well, obviously they tokenize differently. That's one thing. So if we have like alphanumeric characters, something like each digit would be an ID, right? But this is an operator because it's not kind of a non alphanumeric character. And originally I thought that operators would have some special behavior, and they kind of do. So if we look for tag operator maybe, or something, we can see the difference. So the first one is about how we deal with statements. So that's something that is unique to operators. That's interesting. We'll talk about it a bit later. And also there is this whole setup with actually parsing operators. But the thing is that in our actual parsing routine for the expression, there is no real difference between operators and anything else. Let me find it. Yes, so here's our token parse expression. And if we look into the main routine already, then we see that we kind of go through each of the tokens, and we check if it is a value token, so something that wraps a runtime value more or less in the language. And if it is an identifier, it's called symbol now, Then we just try to look up that in the scope of this function. And if it is an operator, so we already support symbols that are operators because macro is an operator right now. If I find something here, probably actually it would be in here. Macro noise, right? So this is technically an operator. It's a prefix operator, and it's not. It's consisting of regular alphanumeric characters, the same as test or ID. So we already support that, but then we have sort of the same thing happening here for for operators. And I think what I'm gonna do today is I'm gonna try to merge those two. There will be no more difference between what is considered like a regular symbol and an operator. They will all do the same thing, and we'll see if it causes any particular problems. The only one I expect is this thing about the statement separator, but we'll see how we can deal with that. To be honest, there are some options. The first thing first is we're just gonna take this out, and that will cause all the code that depends on this type to be very broken, and we will go from there. There is also this token pattern which is used for matching operators, and as you can see, operator and the symbol are already pretty much the same, so we also can take this one out as well. We're just gonna build, we will see all the errors that are coming with that, and we'll go from there. So this will now be symbol. We can replace this with symbol. Okay. So that's that will work. That's a symbol name, not symbol. Let's continue. This stuff is no longer necessary because it is sort of the same. Well, yeah, it is kind of the same, I guess. The only thing is we will no longer be able to switch between operators and the regular symbols in the pattern, but we'll see if that's actually necessary. And we'll just go from there. For now, let's just clean it out. This doesn't make sense. Token match ID actually should be replaced with token match symbol. And that makes sense. Okay, who's next? So we have a push line macro which deals with an operator. We are just gonna change that to be a symbol. And token tag symbol identified. That's right. That's because it's not a symbol, it is actually a value. And then we'll actually need to do some stuff here, so let me mark it for later. Okay, this is now a value as well. But in here we need to do some extra stuff. And namely, we basically need to do this thing. So the only difference between these two now is that this one consumes as long as it is an alphanumeric or underscore, and this one takes care of all the characters for operators. And there is also extra thing here where we need to do this here. So if we come across an end of file before we are done with any of the tokens, so imagine that we had file ending in an identifier, then we still need to push it if we have it. And this is a pretty easy mistake to make in a tokenizer. And now we're taking care of that. And we are ready to jump to the next thing. Maybe not. Actually fix let's actually fix the push line situation. So we have this thing, okay, and that makes sense. So I also need to have a synthesized name for that. Honestly, it might make sense to have a separate thing called statement separator, but we'll see later on. Token make ID, allocator name. Yeah, that makes sense. Is it still passing? No. It is very much broken. So where am I? Something is not right. Okay, till here everything was fine. Okay, I think now that's okay. Okay, that's also okay. Good. Let's bring this stuff back. And see where we are. Okay, good. So that should be fine. We'll see if that makes sense. Actually, this should not be named make ID. It should be make symbol. Okay. Token view match till the end of statement. So that is checking for this stuff. That's okay. I believe that could be replaced with token match symbol, and then we would say token, and a symbol is like this, I guess. Okay, that's fine. There is no more operator, so that's one less to do. Right. So here we are creating fake tokens, and what we need to do here is we're just gonna create them dynamically. Our symbol is semicolon. That's okay. That's okay. And that is okay. And we just remove it here like so. Okay, that should be fine. Who's next? Next is maybe split on operator that we can actually replace pretty easily with token match symbol, token, and operator. This looks pretty neat, I guess. Well, one more to do is gone because it doesn't make sense anymore. Token match operator. Fine, that would be now a symbol. Okay. Huh. This is basically the only place where it makes a difference, I guess. And right. So this function is what is used to parse the operator definition. Um, so something like this, and that's exactly the case that it tries to discern. And the case is if we have a prefix or a positive operator, right? If we have two tokens in this parentheses, then if the operator comes first, then that is the this is the prefix, and otherwise it's suffix. And because we don't really know right now, like we removed an ability to distinguish between this symbol and this symbol, they're all exactly the same for the purpose of the language. I basically have two options. Option number one is to change the syntax of operator definition to be something else, and to so that it's very explicit what of this is an operator and what of that is sort of arguments to that. It's option number one. Option number two would be to actually mark somehow the operator symbols as operators, so that we do know internally where it originally came from. Like, was it something alphanumeric or was it an operator? And I think for now I'll do it that way, although I do want to actually change how operator definitions work. Since I implemented this, I had it quite a lot of thinking, and I think there is some improvement that can be done here. But for now, I just want to make progress. So what I'm gonna do is I'm going to actually add to the symbol the ability to say whether it is this it was originally an operator or not, or rather say, does it have special characters? You would use a bool for something like that, but the thing is, I enabled the feature in C compiler that warns me if I have padding in structs. And the reason you would want that feature is because if you don't have any padding in structs, you suddenly can do memcompare to test the quality, because if you don't, then you can have problems with uninitialized memory between the fields. So that's why I will have to use U64 here, even though it is really, really wasteful. We just need one bit, but we get 64 of them. But that's fine. So how they name this has special characters. I don't even know. Is operator like or something? Mm, whatever. Let's just say is operator like. Or is operator? No, is operator is too misleading. Okay, has special characters. That's fine. And what we're going to do is we're going to go back to tokenization here, and we'll have to slightly change how our, I guess let's update token make symbol to accept that bool has special characters. And we can just add it in here. Okay. Here we will have to say true. And then in here we would say false. I don't really like Boolean arguments, so let's maybe make it slightly better by introducing an enum. And we would say symbol type ID like and operator like. Okay, let's do it like that. Symbol type. So I can actually make it like this, but then I still need to do. Okay, I'm using you. Okay, that's fine. Type padding. Again, I cannot have padding between fields, so that's what I have to do. Okay, if I'm doing it that way, then I will have to now make symbol. All right, it's here. And the symbol type, type. Okay. And here would be symbol and type operator like. Let's bring it to the new line. So you will be ID like, and you would be operator like. Okay, so I guess I do need to split these two again. One is operator, that one is a symbol, and we are okay. Let's reformat this stuff and go from there. Operator name and operator name. And the same stuff here. Good. Right. So this is where things get awkward. Well, I guess not really. So this function is the function that used to parse syntax definitions. Let me show you. So syntax, it used to parse this stuff, and inside of a syntax definition, the strings are treated as kind of symbols, but not thinking about it, it doesn't matter really if this symbol is operator or not. If it comes in quotes, we just consider it a single symbol, and we're gonna be just fine. So I think what we can do is we can say that the pattern tag symbol in here, and then we would just say symbol name is a slice, something like that. That should work, I guess. Okay, target token. Right. Well, and this is a bit more awkward because in here we actually sort of do want the source. To explain what's happening here, like imagine you have a piece of code that says something like x x.foo.bar, and then something like this. So this stuff is the target of the function, and these are the arguments to the function, right? And when we are saying that something is not a function, we basically want to highlight the whole thing, and this will happen because of this source range. But the question is, do I want to also repeat it in the message and say that x.foo.bar is not a function or not? And right now that's achieved through this target token source, but because we removed the source, that's not happening, but we can still use source from source range and targets token source range. I can still do it that way. I'll need to think about it, to be honest. That actually should be like this and like this, I guess. Something along those lines. Okay. Right. Okay, this one needs to be rewritten, to be honest. Because does this work? It's not a member of a function. Is it a member of descriptor? Yes. So actually we can probably do it like that instead and say that it's a previous name and current name. That still might break some tests because okay, it's not a member of a descriptor function. So is it like this then? Right. Okay. Source is not a member of the token. Okay. I guess we will do it the same way. Cool. We don't need that stuff anymore either. This is basically the same problem, which we already know how to solve. And I don't mind that we will use an extra helper for the debugger stuff, as long as the main code stays simpler and it also actually stays smaller, because we removed a field from a very commonly used struct, which is very good. Right, the same sort of problem. So maybe I will actually introduce some kind of macro or helper function to do this stuff, but that's fine for now. Okay, so what is happening here? Here I need to say token as symbol of type name. Right? We don't need this source anymore. Good. Apparently we have a bunch of errors inside of the tests, which we can probably fix. So these checks for the number, and I can no longer check for that correctly. I mean, maybe I should check for the source ranges instead. So maybe a good test would be to actually do this same thing, right? And say that I will take the source like this and verify that it's what it's supposed to be. We'll see. Okay, whatever, let's just put it, let's just put it here. And we can put it here as well. And here, and here, and here. That's actually even an improvement of the test, because we never actually tested that source ranges are correct. And if source ranges are correct, then the actual text that we will get out of there will be correct as well. So that's good. And that's ID, and that's a num. Okay, here you have a string, I guess. Oops. String. Here you have a curly and you have a square. Right, time to run the tests and see how we are. We are just perfect. That means our tokenizer is doing great. We got rid of a field. We can commit 152 and get rid of the source field on all the tokens. Good. Here goes 20 more lines, which is very neat. And I think that's basically all I wanted to do for today. As you see, the changes weren't too difficult, and I will continue making those changes for the rest of the types. So I will get rid of, I think basically the only one left to do is a group. There is nothing really different for that here. All the curly braces stuff, brackets and so on, they will be turned into their own types, and then I will just will be able to get rid of this token stuff. Token pattern actually will be left as it is because we still need to be able to match on these specific types, but all of this will go away, and it should simplify the compiler and open up some interesting opportunities later. For today, that's all. Thank you very much for watching, and hopefully see you next time.